What's up guys, and welcome to this tutorial or walkthrough. We are going to go over question 4 of the 2016 supplementary exam. Okay, so it's called blocks, but it's probably more about forces and Newton's laws. Okay, cool stuff. So two blocks are made of the same material. The blocks have a mass of 12 kilograms and 36 kilograms and are joined together by a light rope. A force F is applied to the 36 kilograms at an angle of 20 degrees to the horizontal as shown. The coefficient of static friction between the surface on which the blocks rest and the blocks is, so mu is equal to 0.7. The blocks do not slide. Okay, so question 4.1, it's a nice question. So question 4.1 says calculate the maximum frictional force that could act on the 12 kilogram block. Okay, so we know that our force friction is equal to mu times the normal force. So mu and then the normal force on the 12 kilogram block. If we just draw the 12 kilogram blocks, we have force friction, we have force tension, and we have our weight and normal force. Okay, so our normal force is going to be equal to mass times gravity in this case. Okay, so mg. So our force friction is equal to 0.7 times mass, which was 12 kilograms, times g, which was 9,8, which is our gravitational constant, and we can calculate the force friction is equal to 82,32 newtons. Yeah, and it is a vector, so we should say left. Okay, so 4.1 we get 3 marks. 4.2 is a definition of, okay, so state Newton's first law. Okay, and it's a definition. Okay, so Newton's first law states that an object continues in a state of rest or uniform velocity unless it is acted on by a net force. Okay, and we get 2 marks for that. Okay, so state the magnitude of the tension in the rope joining the blocks when the blocks are about to start sliding. Give a reason for your answer. Okay, so state the magnitude of the tension. Okay, so for this block to be moving, so 4.3, okay, so when the force tension is equal to the force friction, okay, the blocks will start moving, because then if we look at our free body diagram, if the force tension is greater than the force friction, then the block will move to the right. So the magnitude of the tension, Ft, is equal to force friction, which is of the 12 kilogram, which is equal to 82,32 newtons. And this time it says magnitude of the tension, so we don't care about the direction. Okay, and we get 2 marks. Okay, 4.4 says draw a labeled free body diagram showing all the forces acting on the 36 kilogram block. So question 4.4, a labeled free body diagram. Okay, so we're going to start off with our 36 kilograms, and it's definitely got a weight. It has a normal force, it's got a frictional force, it has force due to tension, and lastly it's got let's call it the force applied, or the applied force. Okay, let's see, we've given all of them labels, and yeah, so that is our free body diagram, and we get 5 marks for that. Very generous. Okay, write an expression for the normal force acting on the 36 kilogram block. Okay, so for the normal force, I'm going to say, I'm actually going to put this in here as well, we have 20 degrees. Okay, so I'm going to say the sum of the forces in the upwards direction is equal to the mass times the acceleration in the upwards direction, and because the block does not lift off of the surface, we can say it's equal to 0. Okay, so what are our upwards forces? We have the normal force, okay, and then we have this component of the applied force which is acting upwards. So we can say plus the force which is applied, I'm going to call that F, the applied force, and we're looking at the sine component, so sine 20. And then the only force acting downwards is weight, so minus weight is equal to 0. So we can say that the normal force is equal to weight minus F sine 20. Okay, and in this case, we can also say is equal to mg minus F sine 20. Okay, yeah. Okay, and that would be our expression, and we get 2 marks for that. Okay, when it says expression, we don't need to input values. Yeah. Okay, and then it says hence, so this would be the final answer. Okay, then it says hence calculate the magnitude of the force F. So magnitude of the force F when the blocks are just about to start sliding. Okay, so how am I going to do this? Okay, so now what I'm going to do is I'm going to also take the sum of the forces in the horizontal direction is equal to, again, I'm going to say it is equal to 0 because it's just as it's about to start sliding. So I'm going to say now we have the F, and this time we're looking at this component here. So F cos 20 minus the forces acting to the left, which is tension, minus force friction. Force friction, I'm going to say, is mu times the normal force. Okay, so is equal to 0. So we're worried about the force F. Okay, but I'm just going to say F cos 20 is equal to T plus mu n. Okay, now what I'm going to do is F is the unknown, cos 20 is equal to tension. We calculated a value was 82,32 plus mu was 0,7, and now I'm going to input the expression that I got for the normal force, which was mg minus F sine 20. Okay, cool stuff. So now we can say that F cos of 20 is equal to 82,32 plus 0.7 mg is equal, okay, we know that we're working with the 36 kilograms, so this mass is equal to 36, so I'm going to say 36 times g, which is 9,8, minus F times 0.7 sine of 20. Okay, now I'm going to say that F, okay, so I'm taking this part of the equation to the left hand side, so F cos 20 plus 0.7 sine 20 is equal to 82,32 plus 0.7 times 36 times 9,8. The only unknown here is this value F. So dividing everything by the bracket, we get that F is equal to 279,26 newtons. And we are only worried about the magnitude, not the direction. So we can get 4 marks for that. And that's the end of that question. Cool stuff. Yeah, so we get 18 marks for this question. Quite a nice, simple, straightforward question. Okay, thanks for watching, guys, and I hope you found this useful.